Hello everyone. This is going to be a quick demonstration of how to set up a GitOps configuration using the Terraform Cloud Operator for Kubernetes. On my left you can see I have a terminal, and on my right I've navigated to the Terraform Helm chart repository for the Terraform Cloud Operator. I'm going to make a few assumptions for this demonstration today. First, I'm going to assume that you have a cluster already available to you. I'm going to assume that you've already got a Terraform Cloud account and that your organization has been connected to your VCS provider. In my case, that's my GitHub account. So you can see that I've connected my GitHub account and that I have an OAuth token ID. So you'll want to copy this OAuth token ID for later in this demonstration. Okay, great. So the first step of this demo is to install the Terraform Cloud Operator using our Helm chart. HashiCorp offers an official Helm chart repository at helm.releases.hashicorp.com. And once you add that repository, you can find the HashiCorp Terraform chart that you can use to install the operator into your cluster. You can see the instructions have this devel flag. That's because the operator is in beta as of this demo. But once we publish the operator for general availability, you'll no longer need the devel switch to actually install the chart. There are two prerequisites for installing the Helm chart. You'll need to create a secret called Terraform RC that contains credentials to access your Terraform Cloud account. And whatever sensitive variables you'll want to pass into your workspace, you'll need to put into the workspace secret. I've got a namespace here called demo, where we're going to be installing the operator. And if we take a look at the secrets in this namespace, you can see that I've already created the Terraform RC and the workspace secrets. Okay, so let's get started. So I'm going to install the Helm chart in the demo namespace with the name operator. And you can see I'm using the devel switch here, but you won't need that once the operator is GA. Okay, great. Looks like that succeeded. So when you install the operator via the Helm chart, it does two things. The first is that it installs a CRD. So if we get CRDs, you can see that you have workspaces.app.terraform.io. This is the CRD that allows you to create workspace custom resources in Terraform Cloud. It also installs a pod. And so you can see that the operator pod is running, and so we should be good to go to get started. So for today's example, I am going to apply the workspace VCS configuration. So what you'll want to do is you want to check out this repository, Terraform Helm. So if you cd into the checked out repository, you'll find an example folder. And this example folder contains several examples for the different capabilities of the Terraform operator. But the example that we will focus on today is the workspace VCS YAML manifest. So if I cat this, you can see that I've already made improvements to the configuration to match my needs. What you want to look out for here is you want to make sure the name of your workspace is what you want it to be, that your organization reflects the name of your organization in Terraform Cloud. You'll want to get your token ID here from the Terraform Cloud configuration page. So you can see that, my VCS manifest, the token ID matches the token ID over here in Terraform Cloud. You'll also want to modify the repo identifier and the module source. In my case, we're going to be showing off with a very simple example module. So this is a root level module with a single main.tf. And you can see if we look into the main.tf, we've just got a random pet resource that's going to create a random pet name of length 8. So that's 8 hyphenated names. Okay, great. So let's apply this manifest. And I'm going to navigate over to Terraform Cloud to my home page so that you can see the workspace being created. Okay, cool. So you can see that the workspace was successfully created. Let's take a look at workspaces. So you can see here 12 seconds ago the VCS workspace was created, and on the right you can see that the workspace was also created in Terraform Cloud. And so if we go in here, you can watch the run happen. You can see that the plan ran, and it said that it was going to create a random pet name of length 8. You see the cost estimation ran, and that the apply succeeded. So we've got two outputs here, lol and ROFL, both containing the random pet name that was created. And so I think a cool part of this integration here is that you can go back to Kubernetes, and if you get the secrets, you can see that there's a new secret created here called VCS outputs 58 seconds ago. And so VCS outputs as you can see here, contains the two outputs that we've configured in this workspace. If we were to inspect the values of those outputs, you can see that there are two base64 encoded values. And so if I copy this over, you can see that once we decode that value, the random pet name that we see here matches the output here. And so this essentially shows you that you can access outputs from your connected VCS configuration within Kubernetes to use in other resources. And that's quite powerful, because if you head over to my example here in main.tf and I edit this main.tf to change the length of my name, so my outputs will be updated. You can go back to the workspace and see that a new run has been queued because of those changes. And so if we click in here and take a look at this, essentially we triggered this run directly from Git by making a change to our Terraform module. The run is going through the works in Terraform Cloud, and once this run completes, it's going to update the secret in Kubernetes via the Terraform Cloud Operator. So you can see that these two outputs were updated with the new length of random pet name that we wanted. And so if we go back here and we take a look at the VCS output secret, you can see that the size of both of these outputs has changed, indicating that the name has probably changed as well. But we can go through and decode the values here as well. And so you can see here that the output was updated successfully as a result of the Git commit that we made. And that's pretty much it. So essentially what I've shown you is how you can set up your GitOps workflow to connect any Terraform module of your choice to your Kubernetes cluster using the Terraform Cloud Operator for Kubernetes. I want to show you one last thing. I also want to show you what it looks like to clean up. So once you're done with this workspace, let's say that you want to clean up after, you simply delete the workspace using the same manifest. And so what you'll see here is that the operator will actually wait until Terraform Cloud successfully deletes the workspace and then returns. Great. Okay, so it's returned, and Terraform Cloud should refresh in a second, and there you go. The workspace has disappeared there as well. So if we get workspaces, no resources, and if we get the secrets, you can see that the VCS output secret was also cleaned up. And there you go. So this demonstration has shown you how to install the Terraform Cloud Operator for Kubernetes. It's shown you how you can create a workspace custom resource after installing the workspace CRD. You can see how that integrates with Terraform Cloud to create the workspace on Terraform Cloud, and can take advantage of the GitHub integration so you can have a full GitOps workflow where most of your module changes are triggered from Git commits. Great. If you have any questions for us, any feedback, any improvements you'd like to see in the operator, we would love to hear it. Please head over to our Terraform Helm repository or the Terraform K8s repository and let us know what your thoughts are and what ideas you might have for how we can improve this. Thanks for listening.